Hello, today we are gonna see the connections of domestic house wiring. So we know that in our houses we have parallel connection so that we can use separately each appliance with a separate switch and to gain equivalent current. So first we start from the supply from pole. So as we know that in every streets and each and every colony we have this kind of pole. So this pole uh, contains three phase generally, three phase and a neutral. Sometimes we see earthing also. So in case of a single phase meter, we know that direct phase and neutral wire comes, which enters into our meter. So our meter contains four wires: line in phase, line in neutral, line out neutral, line out phase. Okay, in this way. So it takes input, right? Then this goes directly to our distribution box. Distribution box generally contain a MCB or isolator. So we have isolator just to turn off and turn on, but MCB, if in case we have MCB, so in that case if any high voltage or overload or any short circuit occurs, they just trip. We see in the old times that we would find fuse. So at that time if the fuse burns, then that would be a main cause and we cannot change it easily. So for that purpose MCB has been invented. Okay, so we see in the distribution box there is a main MCB over here. So this is the main MCB which contains phase and neutral. As we can see, phase and neutral input, sometimes they may be from down also, no issues. So from here it's input and the neutral is directly done to the neutral bus which will be inside the distribution box, so that we can connect multiple neutrals of the house, because we do not connect any switch for the neutral. Okay, and the phase wire remains goes to other each and every MCBs. These MCBs are based on rooms. So for example here only rooms MCB switchboard is given. So we see different amperes for different appliances. For example light MCB, that means of a room's light or anything, 10 ampere. For example here if we see MCB's geezer's MCB which is 16 ampere or 20, we can keep up to 40 ampere each based on our current load. Okay, so here we see earth link also, from which we can take direct earthing. Generally we find earthing in our sockets, but we all can also take. So then these distribution goes to our respective rooms. So as we can see here that this is a room, and some houses we found main switch which is nothing but a double pole switch, which is the main. If we turn on this, then only these work, or else they don't work. But in nowadays we can see that there is no main SPST switch on the switchboard, they are direct connected. But these are quite useful, because whenever, if suppose this socket or switches do not work or they malfunction, we can just turn on them and use, and no need to off any other main. So here for example this is a switch, another switch, and this is other switch. Okay, so light one, this is for this. So if we turn this on, the light will glow. Okay, similarly this one also, the light will glow. And here a fan, so we also know that fan contain a regulator, so no issue, regulator can also be kept. Regulator just adjusts the voltage based on the speed of the fan. Okay, and the other socket which is 5 amps or 6 amps socket, whatever. Sockets generally comes of 6 amps or 16 amps. We also find 20 amp sockets, but they are almost same, right? So in this way this is of a room. Similarly we have kitchen, then balcony, and other room, etc., right? And then now the concept comes to earthing. So we know earthing is a safety device. It reduces the potential difference to zero, and it saves us from electric shocks, as the appliances, some of the appliances contain electrical iron bodies, due to which the earth may spread. So that earthing wire is denoted with green wire. That green wire is connected to the electrode. It may be of, this is here, as here it's shown GI earth electrode, We may also do normal earthing, which is nothing but salt and coal earthing, in which we connect copper plate and we do it earth, right? And also we know chemical earthing, in which a huge long 10 to 15 feet pipe is taken. So for the normal domestic houses, we mostly find this kind of, or the plate, copper plate earthing. Okay, so all metallic parts and earth terminals are connected to earth, and at least we need to connect it 2 to 3 meters deep in the ground. Then we get perfect earthing. And uh, and we know that for single phase we get 220 volt AC, 50 hertz or 60 hertz, and system we have a phase neutral wire, which is combination of 220 volt and earth wire. We should use perfect proper size wire based on the load. So for example, for bulbs and fans we use 0.75 square mm wire to 1 square mm wire. For heavy loads such as AC geyser we use 2.5 square mm to 4 square mm wire. And then mostly we should first make sure that we have proper earthing in our houses, right? And then this is the indication, that is live, neutral, earth. Okay, so in this way, not only one switchboard, we may have in a room several switchboards. Okay, so this was today's topic of single phase 220 volt domestic house wiring diagram with earthing. So in the next video I'm gonna bring three phase connections also. Okay, so thank you.